Okay, so given this function h, we wish to find its derivative. And you'll forgive me, my voice is a bit weak. I did a lot of talking today, but it's all good. Let's do this. So this is h, and we want to find the derivative. Now, if you notice, this function h consists of two main factors. We have this here, and we have this here. So we have to use what they call the product rule. And there's formulas and stuff for the product rule, but it basically always boils down to this. So it's going to be the first piece times the derivative of the second piece, and then plus the second piece times the derivative of the first piece. So let's do this. So what I'm going to do is I'm going to keep the first piece the same. So it's the first piece times, and then in here, I need the derivative of the second piece. Well, what's the derivative of this? Well, let's see. The derivative of sine is cosine. And I keep the stuff inside the same. But then I multiply by the derivative of the angle, which in this case is x cubed. So what's the derivative of x cubed? That'd be, well, 3x squared. So let's see. So I've done the first times the derivative of the second. Boom. Now it's plus the second piece times the derivative of the first piece. And what's the derivative of all of this? It looks like it's just going to be 4, isn't it? So let's clean this up just a little bit, I suppose. Let's see. We can keep this 4x plus 1. And we can call this piece here 3x squared cosine of x cubed addition 4 sine of x cubed. Can this be cleaned up a little more? I suppose maybe your teacher, just close it like that. I suppose maybe the teacher would prefer something like, I don't know, how about this? How about we go 3x squared, 4x plus 1, cosine of x cubed, plus 4 sine of x cubed. Can this be cleaned up any further? I mean, I don't think so. I guess you could do some stuff that I would think is unnecessary. I'm going to go ahead and call this our answer. So this is the derivative, and we use the product rule. So to recap what we did, it's the first piece times the derivative of the second plus the second piece times the derivative of the first piece. In your textbooks, maybe they put this piece here and this piece there, but it doesn't matter because it's addition. That's always how I do these problems. First times derivative second plus second times derivative first. It has a rhyme to it, right? It has a good rhyme to it. I've always memorized it like that. And so regardless of how you want to do this problem, this should be the derivative that you get for h prime of x. And now for this one here, we're given this equation. We want to find dy dx. A quick FYI, if the discussion is dy dx, what would be the dy dx for something like, let's say, 4x cubed? Dy dx of 4x cubed would simply be 12x squared. What about dy dx of something that says like 4y cubed? Well, dy dx of that would be 12y squared. But then you attach a dy dx. How come we do this? Right now, I suppose we'll not focus on the theory of things. Let's just focus on how do I get the right answer? Okay, let's try another one. What if I have something like, let's say, sine of, let's say, x to the fourth. So dy dx of that would be, it would be cosine of x4 times 4x cubed, right? Because I take the derivative of sine, which is cosine. I keep the inside the same, but then I multiply by the derivative of the stuff inside, which is 4x cubed. One more, and then we'll do the main problem. What if I have sine of y to the fourth? What would be dy dx of that? Well, let's see. The derivative of sine is cosine. Keep the stuff inside the same, but then I multiply by the derivative of the stuff inside, which is 4y cubed, but then I attach dy dx. So when you're doing dy dx, if it's just x's, you just do the regular derivative. But if there's a y, you do the regular derivative, but then you attach dy dx. Main problem. Let's see. So I want to find dy dx of this. So I'll attack these one term at a time. If you want, we could get the easy piece out of the way, which is this piece here. That's just going to be 48x squared, right? Pretty straightforward for this piece here. Now, what about, let's say the derivative of this one. This one here. So the derivative of that, well, let's see. The derivative of sine is cosine. Keep the piece inside the same. But then you multiply by the derivative of that, which is 2y to the power of 1 times dy dx. That's a 1, like that. And so I save this one for last. So the derivative of that is that. The derivative of that is that. Now, what's the derivative of this? Well, this is a product rule like the earlier problem. You see, this is one function and this is the other. So let's do what we did just a moment ago, where it's like the first times the derivative of the second plus the second times the derivative of the first. So let me set that up here. So I have the first piece like that times the derivative of the second piece. Well, the derivative of y is just dy dx. So first derivative second plus second piece, which is y, times the derivative of the first piece, which is 8x. So I have essentially done the derivative. Technically, this is the answer, but we have to do a lot of cleaning up, as we usually do in calculus classes. So let's see. So let's clean this up a little bit. That'll be 4x squared dy dx plus 8xy plus, over here, I guess I can call this 2y cosine y squared dy dx equals 48x squared. Now, the goal here is to find dy dx, which means to isolate it. You see how I have one term, I have two term, I have three terms on the left and one term on the right. If you notice, these two terms contain a dy dx, this one does not. So let me move that piece to the other side. And you know what, while I'm at it, actually, let's not rush this. I was gonna multitask this evening, but let's play it safe. So I have this here, and if I'm going too slow, just fast forward the video about 10 seconds or so. You don't have to see me write them if you don't want to. So something like that, minus 8xy. So let's see. So I move this piece to this side because it does not contain a dy dx. Only the pieces that have a dy dx, I leave them on the left because now I'm going to factor out a dy dx as a greatest common factor. And if I factor out dy dx, I'm left with 4x squared, which is just this piece here. And if I remove dy dx from this, I'm left with plus 2y cosine of y squared equals all of this gibberish over here. And now to isolate dy dx, what you'd essentially have to do is divide both sides by that crazy stuff in the parentheses that you see in the sentence above. And so let's see, like this. So this is basically the answer, right? This is basically the answer. Dy dx is alone and it equals all of this. If you want, you could simplify a little bit. For instance, in the numerator, I can take out an 8x as a GCF, and I'm left with 6x minus y over. In the bottom, I can take out a GCF of 2, and I'm left with 2x squared plus y. 2x squared, markers run, the pen is running out. 2x squared plus y times the cosine of y squared. And let's see, I guess the only thing we can do is we can reduce the 2 and call the 8 a 4. So it didn't clean up a whole lot. Kind of disappointing, but whatever. Here is our final answer. 4x, parentheses, 6x minus y over 2x squared plus y cosine of y squared. If the textbook or the teacher has something different, please let me know and I'll explain what they did. But this should be the result. So again, let me know if you have any questions.